Welcome back, data nerds. What's up? Let me give you a quick recap on what we did in the last session. We took a quick tour of a tool called SQL Workbench, which is going to be a very important tool for a few upcoming sessions. Having said that, if you have any other tool already installed in your system, you can go ahead and use that as well. The syntaxes differ a little bit here and there, but the logic behind it, the concept behind it remains almost same. Okay, so let's get started. This was a query that we wrote in the last session, which was create database if not exists, sales. This query was mainly divided into two parts. So the first part was create database, where you give command to SQL Workbench to create a database. But before that, you also wrote something called if not exists. Now this part checks in the storage that do we already have a database called sales? If not, then create the database. So that's what this query means. And after we refreshed the schema, we successfully were able to create this sales database. Okay, and we have gotten this small drop down. If we just click on that, we can find table, view, stored procedures, functions. But as you can see currently, if we click on table, nothing happens because we have not created any table inside the database. But before we jump on creating a table and inserting rows inside it, I would like to give you a quick concept overview about a database. So let's understand that. Just imagine database is like a storeroom where you keep your things. You come here, you dump everything. That is what a database is all about. That was a layman's term example, but if you actually want to learn it technically, it says that it's a digital repository. It's a repository where you keep things. That's it. In database case, it's a digital repository because you do not have tangible things to keep it there, right? Things are all intangible. So it's a digital repository for storing, managing, and securing organized collections of data. Again, very important. In database, you do not just store things, but it helps you manage, and whenever you need, it helps you retrieve the data from the database as well. And that is one of the important qualities and characteristics of database, which has helped shape the whole data industry. And then it says it's a structured system for storing, managing, and retrieving data, exactly what we talked about, enabling everything from simple record keeping to powering complex applications and services. Yes, whatever applications do you use, if you are using anything on web browser, if you have any financial tracking application, whatever you use, these all applications and websites rely heavily on the database. Whenever you search something on Flipkart or Amazon, the results appear quickly, right? So where do you think the search results were stored? They were stored in database, and they were connected in such a way that whenever you search, they appear on your screen quickly. That is the concept where we say that these applications and websites rely heavily on database because everything's stored there. So just understand for now that database is a digital repository where we store things, where we manage it, and whenever required, it's built in such a way that we can retrieve whatever, whenever we want. So that's how it works, okay? That was about database, which we have already created in our SQL. Here, imagine a space has been created. Now you want to create a table. You want to put your actual data, right? For that, first you would need to create a table. Inside table, you'd like to have your rows and your columns. So that would be your next step. We want to create a table. But before we jump on writing the table query, we should first give command to SQL Workbench, which will tell that we want to insert the table in this database only. Because we already have one more database called Awesome Chocolates. Do we want to create a table there? No, we want to create inside sales. So what are we supposed to do? We're supposed to write one query which will go something like use sales. This would give a command to the SQL Workbench that this database should be used after that. Whatever I'm going to create, it should be stored inside this database. I'm just going to run this. Yeah. You see in the result grid, it gave a command to SQL that, okay, fine. After that, whatever I'm going to do, that should be done inside this database and not here. So that was the whole purpose of writing this query. Since we are done with that, the next step would be understanding how do we create a table inside a database. Let's go back to, so the very first step that you have to do before you create a table is deciding the table name. Of course, very basic, right? And then you're going to write this query, this 2-word simple query. If you remember when we were creating a database, what did we write? Create database, right? Similarly, we're going to write here, create table. So that is the 2 important keywords we're going to use here. This is our query. After that, you see people. People is nothing but the name of the table. This will tell SQL that I'm going to create a table named people. Okay, fine. The first step is done. What about the next steps? Let's go. Next step would be define column fields and assign data types. So now since you have told SQL that my table name is going to be people. Inside that, now you would like to have columns, right? You are also supposed to decide that what data types those columns are going to be of. Maybe you have columns like name. So name is of what? Name is a text. But then you have age. Age is not a text. Age is a whole number, and that would be somewhere numeric, integer. Then you have salary. Again, salary is also not a text. You have to give this column as other data type, maybe integer or numeric. Then you have something called address. Again, address would be your text. So these kinds of command you have to give to your SQL so they can start creating the table accordingly. And that is what we are going to do now. It says that inside brackets, define what data you want to store, and each column is equal to one type of information. You will understand when you see this. So this is how it looks. First, you are giving the column name. Salesperson is nothing but the column name, right? So my first column is going to be salesperson, and that's why I'm written here. Second is giving the data type instructions. So the salesperson, it's a name, right? And name has to be text. And for that, we are using a data type called varchar. And after varchar, we have written 100 in the bracket, which says that max to max 100 letters are allowed for a salesperson, which is enough. I don't think anybody will have more than 100 letters in their name. So it says that 100 characters are allowed for this column, which is salesperson. So what are you doing? First, you are defining the name of the column, and then you are giving the data type, and then you are also telling if it's a text, you are actually limiting that what should be the number of characters allowed, maximum number of characters allowed. So that was about salesperson. Then you have SPID. There will be an ID because names can be repeating, but that ID will be unique to everyone in the organization. So your ID is going to play a very important role. So that's why I've written SPID varchar. Maximum character this ID should have is 10. And then you have given this primary key, which is nothing, which shows that this SPID is going to be unique. Your name cannot be unique, people's age cannot be unique, their salary cannot be unique, but you should have a column which is absolutely unique and does not repeat. So in our case, that is our SPID. And that's why we have written something called primary key. This is a constraint. If you remember, I have already talked about primary key and foreign key in much detail in one of my sessions. I'll pin that video somewhere. I would like you to go back and just revise your concept once more before you actually write this table, because that will help you understand that why are we writing primary key here. Just for your refresher, I will tell you in one line. Primary key tells that this column is unique and this cannot be null. So it's possible that while entering the data in the database, the name can go null, maybe the age is not there, but the ID should not be null. It should have information. So that's what primary key makes sure. Okay. Then comes age. Again, as I told you, that age has to be integer. So first you are writing the column's name, and then you are giving the data type, which is integer. Then you have salary, which is also an integer. Then you have team, which is varchar 50. Then location, varchar 50. Right? It says that salesperson, the column's name is salesperson, which is nothing but a name, and the data type is text. Then SPID, which is nothing but ID, and the data type is text ID. Age, data type is whole number, salary is whole number, team is team name, and again the data type is text. And same with location, the data type is text. Okay. Now for you, I have written a small definition of varchar. It's nothing but it stands for variable character. It's a data type used to store text or strings, right? As you already saw that we had varchar written in the column name salesperson, because salesperson is going to be a text. And that's where we wrote it. And the next thing was this number inside the bracket. So it says the number inside brackets is equal to maximum number of characters allowed. As I already told you, that the 100 tells that you can max to max, the salesperson can have a name which has 100 characters, not more than that. So we are done defining the table name. We are done writing the column names, assigning the data types. We are done with the main work. Now what? Let's understand. Add constants. Now, as I already told you, that you saw a different thing here, primary key, which was only given to SPID and it was not given to any other columns. Why? The reason I already told you, that we need to have one column which is going to be unique, which is not going to be null. That helps us establish the relationship with other tables. And once you are done with these things, your table is ready. So shall we write that? Let's go. So we are back on our SQL workbench, and let's start inserting the columns inside our table. First, we have to define the table name. And what was the process for that? Create table. And what was the table's name? The table's name was anything, maybe people. In my case, it's people. And after that, we are going to open the parenthesis, enter. After opening parenthesis, we'll write the column name, which we are going to give. The first column name would be salesperson, in my case. And after that, we are going to assign the data type. The salesperson would be a text data type. For that, we are going to write varchar. Yeah, you already get these suggestions. So just click on tab. In brackets, we are going to give the maximum limit of characters this text can have, which is 100. Okay, so first column name is done. Assigning data type to that column name is already done. Comma, enter. Okay, now we'll come to the next column. The next column would be ID. So that was SPID. And here again, we are going to assign the data type, which is again varchar. And this would be 10 because ID will not have more than 10 letters, right? Again, comma, we'll move towards the next column, which is going to be maybe age. And what will be the data type of the age? It will be int, right? Because age is going to be whole number, and whenever you have a data type which is whole number, you give it int. This is done. Next was after comma, we're going to add next column, which is salary. Again, the data type would be int. Then comes the next one, which would be team. So team, column name. And again, the data type would be varchar. And this would be maybe 50, right? Team name is not going to be more than that, comma. And then the last column name would be location. Data type is varchar, and this is going to be 50. Looks like we are done, right? We have already created the table, we have named our table, then we have introduced the column names. These are the columns names, and we have also assigned the data type to our columns. So looks like we are done, but are we? There's one important step which is missing, and that is adding the constraints, adding the rules. So that we're going to do now, okay? And which column is going to be our primary key? This SPID. So all we have to do is after bracket, just give some space and write primary key. This would automatically understand that, okay, you are making your this column as a primary key. And that's it, you are done. So now your table creation process is completed. Let's run this and see that are we right or wrong. As this says that we have successfully created a table. Let's go to the database. Right click, refresh. And yep, inside table now we have something called people. If you click, you would see the columns have been created. Now let's call this table and see what exactly, is there anything inside, because we have not inserted any values inside that column, right? So let's call them and see what happens. Select everything from people. We have columns ready. It has given me the column names, but it does not have any value inside those columns. Those rows are empty, so that's why it's giving me null, null, null everywhere. And that's how it was expected, right? Because we have not added anything inside columns. But the good part is that we were successful in creating a table. Now comes the next part, which is inserting values in those tables. Let's learn that first. So let's figure out what will be our first step while inserting data values in the table. The first step would be decide the table name. Of course, you have to decide the table name, that in which table you are going to insert all your data values. Okay. For that, we are going to write insert into people. These will be your first two important keywords. Here you will write insert into. That will tell SQL that, okay, this person is trying to insert something in the table called people. Right? So you're writing insert into people. This means that you are telling SQL that I'm trying to insert data into the people table. Okay, so that was your first step. The second step would be specify columns. So you have to specify that what were my columns, right? And this is how you're going to specify your columns. You are going to tell that my first column was salesperson, then I had SPID, then I have age, then I have salary and team and location. You are going to tell SQL that this is going to be the order of my table. Okay. And what would be the next step? Next step would be you would start actually inserting the values inside those columns. And they would be something like this, right? So you would write values. After insert people, you would specify the columns, and then you would write values, and below the values, you will actually write the values that you want to enter in that table. So my first column was salesperson, right? Now the salesperson's name was John, the SPID was SP01, the age was 25, the salary was 5,000, team name was Yummies, and location was Hyderabad. So this is how you are going to specify the columns and then the values inside that, okay? Now, what if you have to insert multiple rows? This was this example of just one row, right? But your table will have multiple rows and multiple columns. You have figured out the column thing. But what about if you're going to add multiple rows? Then you would just repeat the same step. The way you wrote this line, in similar format, in a similar thing, you're going to write like this. You'll just change the name, you'll write the details, and you are just going to follow the same column name order, and you're going to insert the values. So this is how you're going to write it. Shall we start writing? Let's go. We are again back to the SQL workbench. We are going to insert values. So what were the first two keywords? It was insert into. Do not forget that. Insert into. And then you have to specify the table name in which you are going to insert the values. What was your table name? It was people. Well, we are done with that. Make some space. Open the parenthesis. Then come down. So once you are done with insert into and people, you have told SQL that I'm trying to insert something in the table called people. You would come down, you would open the parenthesis, and you would give the column names. So what were our column names? They were salesperson. I'm just taking the reference of this and I'm writing the column names. SPID, then we have age, then we have salary, then we have team. This would help you maintain the after team there was supposed to be a comma. This would help you maintain the order of the column, which is very important. And once you are done giving the column names and their order, you will write something called values. After that, you'll start a bracket and then you'll start writing the actual values for these columns. So first column is what? Salesperson. What should be the salesperson's name? Imagine first would be data girl, maybe. SPID would be SP01. Okay, so what were the data type of salesperson in SPID? It was VARCHAR. It was text, right? And whenever you are inserting a text value inside a table, it should go inside these inverted comma. So that tells SQL that, okay, this data type is text, and that's why I'm giving exactly that value. So you always have to surround it with inverted comma. Let's get the age as 25. Now, 25 is an int. It's a whole number, and that's why I'm not giving it inside inverted comma. Remember, you always give text type inside inverted comma. You do not give your integer values inside the inverted comma. So I'm not going to give that. Then salary, maybe, let's take 25,000. Okay. And then the team would be the best team. I'm going to give best team. Yeah. And the location would be, let's take Bangalore. Sorry, Bangalore was supposed to be inside the inverted comma. So there goes the first row for our table is created. Okay, let's close this. And let's run, and we'll see that whether we were successful in inserting these columns in our table. Let's check. Just run. And yes, it says that, yeah, insert into was successful. How do we check that? Again, we'll write select everything from the table name. Let's check. Oh yes, we were successfully able to insert those values inside the table people, right? You see it's written data girl inside the salesperson, and my ID, my age, my salary, my team, my location. So everything has been successfully updated here. But now only one row is updated. I would like to have multiple rows. Yes, so I have added a lot of rows in my table because before I just had one row and which was not making any sense. So I have added these many number of rows. I would paste this code in the description box, and you can just practice adding 1 or 2 rows, and after that you can just copy and paste these number of rows. Okay, let's select and run this and see that whether, yep, it says that insert into was successful. So now our table should have these many number of rows. Shall we run it and see? So we have already select everything from people, so we're just going to select it and run. And yeah, as you can see that all those number of rows that we just added, we can see inside our table. Rahul, Mehta, Sneha, Iyer, Amit, Sharma, all these names and their SPID, their age, their salary, their team, their location, everything is added. I deliberately added this null because I wanted to show that this kinds of data discrepancy you would be very frequently seeing when you are actually working with these things, okay? So what we did, we have already created the database, we created a table, we inserted columns inside that, and then we inserted values inside those columns. Then we inserted a lot of rows inside our table, right? So we are done with these steps. So now my question is that we all are humans and we tend to make mistakes. What if we created an extra column or maybe an extra table which was not at all needed? And what if we want to delete them? We want to drop them. For that, SQL gives us 3 important functions: delete, drop, and truncate. Let's understand these 3 functions in detail now. So this is a tabular form of differentiation which I have created for you you can take a screenshot if you want. And this tells you that what is the difference between delete, drop, and truncate. So delete is a DML command, drop is a DDL command, and truncate is a DDL command. Now, why do we say that delete is a DML command? DML command is nothing but data manipulation language, okay? Why do we say that delete is not a data definition language command, but it is a data manipulation language command? We say that because when you actually write this delete function, you are not changing the whole structure of the table. You are not messing up with that. You're just trying to tweak the data inside the table. You're not trying to change the structure of the table or the structure of the database at all. And that's why it's called a data manipulation command, because you are just manipulating the data inside the table and you're not changing the structure of the table at all. Then comes drop, which is a DDL command, which is a data definition language command, because this messes up with the structure of the database objects. As it says that it is used to define or change the structure of the database objects, right? How? I'll tell you. Then we have truncate. Again, this is also not just a DML command. This is also not just to manipulate the data inside a table, but it is also a DDL command, which is data definition language, because it is also used to change the structure of database objects. So you have to be very sure when you're using these DDL commands. So delete actually helps you delete few rows based on a condition. Maybe you want to delete a row where the salesperson name is the data girl. So you just have to write the condition and that row will be deleted. So that's how this delete function works. So in delete function, you are not changing anything of the whole table. You are just giving a command to SQL that delete this row where the salesperson name was the data girl. Maybe she has left the organization and I do not want to have her data stored in my table. So I just want to delete that row. So it just goes and delete that particular row as commanded. But what happens if you actually use the drop? It deletes the entire table or the database. So it actually, as I told you, it messes up with the whole structure of the database and its objects. Okay, so you have to be absolutely sure when you are using this drop function. So drop removes the entire table and the database, and that's why it is a DDL command. It messes up with the whole definition of your database and its objects. Then comes truncate. And what does truncate do? It deletes all the rows from a table. So it works exactly opposite to delete. You know, in delete, you want to delete one row, you give the command and that one row will be deleted. But if you use truncate, all the rows of that table will be deleted. So you have to be very sure. Then comes which can be rolled back and which cannot be rolled back. Means maybe you deleted something by mistake. Can you retrieve it? And what can you not retrieve? So in case of delete, if you have used delete, that can be rolled back. But if you have used drop and truncate, they cannot be rolled back. That's why you have to be very sure and you should have all the permissions before you use these functions. Okay. Then comes data removal. Of course, if you are deleting any row, then it will be deleting the selected rows. It will delete the whole table and the data completely, and it will delete all the rows. Okay. So that was it. Then comes efficiency. Since it deletes on individual levels, so it will search for that condition that, okay, where is this column, the salesperson, and where data girl is written inside it, which is that row, and then it will delete. So as compared to drop and truncate, this function is a little slower. Then comes drop. Of course, it's instant because it's removing the whole database and whole table. And yeah, truncate somewhere lies between the delete and drop when it comes to efficiency, because it's faster than delete as it does not work on any condition, but slower than drop. Okay. I have also given you one example that if you want to delete, so it says that delete from table name where SPID is equal to SP11. We'll write this example in our next session in the SQL, and I'll explain you what is this where clause and what is this, how are we using delete function, and what happens after we do that. We'll do everything, okay? So for now, just understand that this is how it looks when you write delete from people where SPID is equal to SP11. If you want to drop a table, you just write drop table and the table's name, and the table will be dropped. And truncate, again, if you want to remove all the rows from the people's table, you just have to write truncate table people. All rows from the people will be gone. So this was about it in today's session, and I hope you learned how to create a database and how to create a table, how to insert values inside it, what is the use of delete, drop and truncate. So for now, this is it. In our next session, I'm going to show you how do we use delete, drop and truncate, and we are actually going to drop few tables to understand that what exactly happens here. So yes, I hope it's helping you, and if it is helping you, then do not stop practicing. Do not just watch video. Download any tool in your system and start practicing. That is the only way to learn. So practice, study hard, and meet me in the next session. Bye bye.